Let's tackle example 3. So again, let's find the discriminant, which is b squared minus 4ac. So let's find the a, b, and c. So a is the number in front of x squared, which I don't see a number in front of x squared. So what's secretly in front of the x squared? That would be a 1. So my a is 1, my b is 4, and my c is 5. Okay, so let's solve the discriminant. So b squared would be 4 squared, and then minus 4 times a, which is 1, times c, which is 5. All right, let's solve this thing. So 4 squared is 16. 4 times 4 is 16. And then negative 4 times 1 is negative 4. And negative 4 times 5 is negative 20. And 16 minus 20 is negative 4. Okay, so our discriminant this time is a negative, which means it's less than 0. Everything less than 0 is negative. So you have like negative 1, negative 2, negative 3, things like that. So this time my discriminant, I did better this time. Yes. All right, discriminant is less than 0 this time. So remember, you guys, the discriminant is going to be underneath the square root in the quadratic formula. And which types of numbers do you get when you have a negative underneath your square root? You would end up with an imaginary number. But since the quadratic formula has like negative b plus a number over a number, you're going to have a real number with an imaginary number, which we call numbers that have real and imaginary components complex. So we know that our roots are going to be complex, and that we're going to get 2 of them because we're going to add and subtract an imaginary number to whatever negative b is, and then we're going to divide it by 2a. So again, going back to your cheat sheet, so when the discriminant is 0, you're going to get 2 complex roots. And remember, when you have complex roots, your graph is never going to cross the x-axis. In our last problem, we had d equal to 0. Remember, that's a double root, and your graph will bounce off the 0, which is called being tangent. And in the first problem, we had 2 real roots, which means it crosses the graph 2 times. So 2 times, technically 1 time, well, it looks like once, but it still counts twice, so it's kind of weird. But it's bouncing off the 0, which is called tangent, and then it never crosses the x-axis. So this is what your answer will look like graphically, which is pretty cool. Okay, so from my final answer, sorry, dropping things everywhere. The demon cats are getting me. All right, so for my final answer, we're going to end up with 2 complex roots. There we go. And that's it, you guys.